Good morning, everyone. Today we are moving on to two new graphs. The first one we're going to look at is the graph of the cosine function. You can start here on the page 521. The second video we'll look at our tangent function. Similar to last week, we'll have two different worksheets working on each skill. Okay, so to start with the cosine graph, here's what I want to do. I kind of want to start the same way we started with the sine curve. And I want to start plugging in x values to find y's. Now remember, in these graphs, in these trig functions, the x value, the input, is the angle of the various triangles from around the unit circle, and the y value is the ratio of the sides, right? So I don't want you to lose track of that. I know we're using a y here, but that y is really, in this case, is going to be the cosine, which is the x value. So if we think about what we saw in the last unit, right? Here's our unit circle. When x is 0, when the angle is 0, this point here was 1, 0. So the cosine of 0 is 1. It's the x value at that point. If I start rotating around the unit circle, the next angle we looked at was pi over 6. Just like with the sine graphs, we're going to focus on the radian measures when we graph. The cosine at pi over 6 is root 3 divided by 2. If I move up my angle up to 45 degrees, which is the same as pi over 4, right? The pi over 6 up here was the same as pi over 6 is the same as 30 degrees. Pi over 4 is the same as my 45 degree. If I did that special right triangle, the x value was root 2 over 2. The cosine value is at root 2 over 2. Then I went up to pi over 3. That was my another 30, 60, 90. Pi over 3. But up here, the x value at this point was 1/2. And if I go straight up, right, pi over 2 up here, that has 0, 1, xy. So at pi over 2, my x value is 0. Okay? So let's see what these points look like. 0, 1, pretty easy to graph right there. Pi divided by 6 is approximately 1/2, right? A little over 1/2. And the square root of 3 divided by 2 is about, I did multiply by 2. Divided by 2 gives us about 0.86. So when we're a little bit over 1/2, we're up at 0.86, which is maybe right about there, right? Or so. Pi over 4 give me an x value of 0.78, so maybe about 0.8, so maybe right about there. And root 2 divided by 2, and again, I'm just getting all these decimal values here, is about 0.7. So a little bit less, right about there, is my next point. Okay. Next, pi over 3. So pi divided by 3 is a little over 1. So now we're over here a little over 1. And then we're at 1/2. So a little over 1 and 1/2 is right about there. So you can see what we're having here. We're having that same curve, that same shape that we saw with our sine curves. Instead of starting down here at the origin, though, the cosine graph is starting up here at 1 because the cosine at 0, angle 0, is 1. All right? And then pi divided by 2, which is 1.6 or so, we're finally down here at 0. All right. So here is the start of the cosine curve. It's going to look very similar to the start of the sine curve. There. All right. So we got a curve. We don't need to keep going with all these in between values, right? We want to get those 5 key values just like we saw with sine. So the first one is 0, 1, pi over 2, 0. Then we want to go to pi. Pi is straight to the left here, right? The cosine value there is -1. I'm going to go 3 pi over 2. That cosine value is 0. And then I want to go back to 2 pi, which has a cosine pi value of 1. So just like with sine, I'm worried about these 5 key values. There's 1 and then these 4, right? Those are the 4 I want to be able, the 5 points I want to be able to graph every time. So pi is 3.14. We're down at -1. Okay. 3 pi divided by 2 as a decimal is 4.7. So 4.7, I'm here, I'm back at 0. And then at 2 pi, which is 6.28, I'm back up at 1. All right? So the cosine curve, when we graph one period, it has a slightly different look than the sine curve because of what the cosine of 0 is. The cosine of 0 is 1. That's why it looks like this graph is starting up here, right? The sine of 0 is 0, so the sine curve started down at the origin. So these graphs are going to be very similar. We're going to graph them pretty much the same way, finding the 5 key values in the XY table I talked about. These curves keep going in both directions, right? So if I keep going over here to the left, I'm going to see the curve. If I keep going over here to the right, I'm going to see the curve. That just repeats over and over again. When I graph one period for cosine, this is what I'm going to be seeing. Now remember, this is a snapshot of the graph. This is just one period. The domain today is still going to be all real numbers for these cosine graphs. Okay, so let's fill in a similar chart like we did with sine. Okay, the period, still 2 pi. So the little formula we use is still going to be 2 pi divided by the b value. The amplitude for the parent function is 1. The midline here is still y equals 0. Midline, again, is this horizontal line that goes through the horizontal middle of the graph. And the domain, even though we're just graphing one period, the domain is still all real numbers, so negative infinity to infinity. And the range is just -1 to 1. All right. So a lot of similarities here between the sine graph and the cosine graph. You just have to keep straight what these 5 values are that we're starting up here. 0, 1, and then pi over 2, pi, 3 pi over 2, and 2 pi. Okay? Now, we're not going to do the little thing we did with the sine curve where you graph a bunch of different ones. I don't care what goes here right now. Today it's going to be cosine, but the amplitude is still the a value, and the period is still 2 pi divided by b. So all we're changing is the function, and the a and the b value do the same thing. So let's go ahead and graph a few of these. I think I have 3 here that I want to graph, and then I'm going to let you guys start the worksheet. Okay? So this is on page 522 in your book. We want to graph y equals 3 cosine of x. Okay? So because there is no b value, the period is still 2 pi. Because there's an a value out front, we know the amplitude is going to be 3. Midline for right now is y equals 0, and we'll come back and do domain and range in a second. So this graph is starting here at 0, and because the period's 2 pi, it's going to end out here at 2 pi. So just like with the sine curve, we have to find the 5 key values in between. Halfway between 0 and pi, halfway between 0 and 2 pi is pi, right? Add them up, times by half. You find this, halfway between pi, let me get rid of this, halfway between pi and 2 pi, if I add pi plus 2 pi, I get 3 pi. 3 pi divided by 2 is 3 pi over 2. And then over here, this point here, halfway between 0 and pi, is pi over 2. All right. So those are my x values. Because the amplitude here is 3, I'm going to start up here at, I'm going to go all the way up to 3. I'm going to go all the way down to -3. And because this is the cosine curve, it's the first key value is up there at the top of the curve. Then I'm working my way down there to the middle, all the way down to -3, back up to the midline, and then back up to the top. So it's still one period. We're still going to graph how long it takes for us to start repeating. There we go. Until we start to repeat the graph. Just trying to move this pi over 2. I want to put this above it. Same with the 3 pi over 2. So I'm going to put this, I'm going to put that in afterward because I want to sketch a nice graph. So here's the graph coming down. Again, remember these are nice, not loops, but curves, right? No V's, nothing like that. All right, so this was 3 pi over 2, and this x value here was pi over 2. All right. Domain, all real numbers, so -infinity to infinity. And the range is -3 to 3. All right. So again, a lot of similarities between the cosine and our sine curve, right? Just slightly different shape. But again, this graph goes on forever in both ways. So really, when you look at it, it looks just like a sine curve, just shifted over a little bit to the left and right. And on Thursday, we're going to start talking about what's called a phase shift, which is moving things left and right. Okay, let's try this one. What I'm doing here is I'm going to have one and we're going to do together, one you're going to try on your own. This has a little bit of everything. It's got an A and a B value. So the period here is 2 pi divided by 3. The amplitude's 2. And the midline is going to be y equals 0. So amplitude 2, I'm going up to 2, down here to -2, okay? Starting at 0, but now my period is only 2 pi over 3. So I'm going to stop out here at 2 pi over 3. Now again, I've got to be able to find these 5 key values. Halfway between 2 pi over 3 and 0, add those up times by half, I get pi over 3, right? Halfway between 0 and pi over 3 is pi over 6. Halfway between pi over 3 and 2 pi over 3, again, you can add those up. Pi over 3 plus 2 pi over 3, that's kind of nice. That's just pi. And divide that by 2 is pi over 2. Okay, so again, you have to be able to find those 5 key values along the x-axis. Cosine curve starts here. It's going to work its way down to the lowest part, back up to the midline, and then back up to the highest part, and that's where it starts repeating. So that's one period, and we can stop graphing there. Curve looks like it did in the last few. Again, nice and smooth. Do the best you can. It's kind of hard. It's hard at times on the iPad to get it, but all right, there we go. Domain is -infinity to infinity, and the range for this one is -2 to 2. Okay. And that's it. Let's try one here on your own. So I'm going to pause the video. I'm going to take a sip of water, pause the video, and see what you can do with this one. This one's got a little trick to it. Think about how you're going to handle this negative out front. Okay, so let's talk about the negative in a second. First, let's find the period. And the period here is 2 pi divided by 1/2. When you multiply by this reciprocal, you get a 4 pi for your period. Amplitude is 5. Now, technically, the amplitude will never be negative because the amplitude is the distance from the midline to the top and the midline to the bottom. Right? We said it's the difference between the range, the high point of the range and low point of the range. But now, this negative, we haven't seen one of these yet, but that negative is a negative a value out front. That is a vertical flip. It takes everything and flips it top to bottom, bottom to top, flips it over the x-axis. So instead of having a point starting up here, right, and having a curve that looks like this, we're going to flip that down and have a curve that looks something like that. Right, now it's a very messy picture, but that's what a negative out front does. It's going to flip the graph. Okay, so I'm going to go by 2's here. I'm going to go down here and make this a -6. I'm going to go up here and make this a +6 since my amplitude's 5. So that means instead of starting up here at 5, I'm going to start down here at -5. Then, well, let's do the x-axis. That is my starting point. That's okay. So here's 0. My period is 4 pi, right? So 5 key values in between. Halfway between 0 and 4 pi is 2 pi. Halfway between 0 and 2 pi is just pi. And then this guy over here is just 3 pi. So that's a pretty straightforward x-axis. Now, because of the negative out front, I flipped it down. This is my starting point down here. Next key value is going to be at the midline. Then up at the top, which is going to be up at +5. Then back to the midline, and then back down to the low point at -5, right? So my curve, instead of having like a U shape, as in basically an upside down U shape now, because of the vertical flip. But remember, Doesn't matter, this curve keeps going and going and going. We're just graphing one period of it. Okay? Midline is y equals 0. Domain, negative infinity to infinity. And the range for this graph is from -5 to +5. Okay. So that's it for the cosine graph. The tangent graph is a different animal. We'll work on that in the next video. I would pause the video and go do this worksheet. It's on Schoology. The answers are on Schoology as well. When you're done, submit it. Make sure to show me all your work. If there's any questions on either of the videos, make sure to stop into the office hour today or on Thursday.